Today we will discuss about the novel structures of RF observers. As we are already aware that mostly SRR and array of SRR are being used to introduce a structure of radio frequency RF observers. These structures are being designed or built in such a way that their permittivity or permeability takes the shape of DNG. DNG is nothing but double negative material, or you can say these are being used to have negative permittivity and negative permeability. Why we are using these metamaterial for RF observer? The reason being that they are capable to offer first reflection and second reflection as 180 degree out of phase, and because of this 180 degree out of phase, the reflections get cancelled out, and we will be able to get perfect absorption. So far the incident wave is placed in normal, the absorption is sufficient enough, but the problem is when the incidence angle is oblique. So we need to integrate some sort of techniques so that even if the angle of incidence is varying, we must be able to get the reflections cancelled and resulting into perfect absorption. So there are various techniques being built depending on the architecture or structure of the SRR in such a way that the angle reversal takes place, and there won't be any reflections, only the absorption will be there. Reason being, the first reflection and second reflection angle is out of phase and they get cancelled out. Now the second is that how to compute the loss power or the absorbed power. Basically the absorbed power is depending on the volume of dielectric substrate as well as on the surface area of metallic part. There are two formulations being used in any of the observer, that is, one, PD is equal to pi epsilon f tan delta integration of E mod square dV, where volume of substrate is taking part to compute the dielectric absorbed energy. The second part is the metallic part, and that can be computed with the formulation Pm is equal to 1 by 2 under root pi mu f upon sigma integration of S h mod square ds, that is the surface area of the metallic part. So we could find out that 80% of the absorption power is due to the dielectric substrate and 20% of the absorbed power is due to metallic surface. So the substrate will have three dimensions, generally ABD, so it will cater to the volume. That is why the PD will be depending on the volume of the substrate being used, and that is 80% of the power loss, and 20% will be depending on the surface area of the metallic part, that is conducting surface. So this amounts to 100% absorption, or mod magnitude 1 is the total absorption. But because of recent research, there has been development that we can reverse the scenario, or even we can improve the scenario. The metallic part can be developed in such a way using different architecture and structures that the power loss due to metallic part will be approximately more than 95 or better than 90% at least, and the power absorbed by dielectric substrate will be lesser than 10%. Sometime it may be 99 and 1% the configuration. This will be because nowadays 3D inkjet printers are available, and we can use the resistive ink in the structure. The structure is being built in such a way that the current is being absorbed by the resistive network, and this resistive network is being formed by using ink of specific material. So the very thin or of low profile substrate will be used to design these RF absorbers. Hence, now even single layer RF absorber will be able to give a very huge amount of absorption. But these absorption, these type of structures which are being built as absorber are being generally used for steel applications. Reason being, very thin sheet, or there are various type of paints which can be used as a surface for carrying out this type of structures being built with using 3D printers or inkjet printers, and they can be bent, or depending on the structure of the surface where we want to apply, they can be bent, they can be built in that particular type of surface. Hence, with the help of the research, thin metamaterial single layer RF absorbers offer 95% of absorption due to metallic structure, and only 5% or lower than 5% absorption is being offered by the substrate. These are the novel structures being built in such a way that they can not only control the absorption part, but they can be built in such a way that they are polarization insensitive. Reason being, the structure is placed in such a way that each ring or each cell will be placed with 90-degree phase shift, and in total they can offer 360-degree phase shift, and they can be developed angle insensitive. If the normal incident wave is there, then also absorption is similar, and even if the oblique angle incidence is there, at that time also the absorption will be same as compared to the normal incidence. So this is broad area where the researchers need to work, that they should be able to develop a structure in such a way that even if the angle of incidence is oblique, still it must be able to offer you the absorption as equal to the structure which is offering a absorption equal to unity. So this is that's all for today's class. We'll discuss the other features in the next class.